Welcome to SSV tutorials. Today we are discussing the topics about the heat in that evaporation. It is an important phenomenon of heat. So what is meant by evaporation? First I want to tell the definition of evaporation, that is the escaping water or liquid molecules from the surface of liquid at any temperature. The escaping liquid molecules from the surface of liquid at any temperature is called evaporation. Simply, it is the nature of the substance which is converting from liquid state to gaseous state. Any liquid, the change of the state of the liquid from liquid to gases is called evaporation. Here, this point at any temperature is important. Another definition also there for the evaporation, that is, evaporation is the change of state of liquid into gases at the surface of liquid. The change of state of a liquid into gases at the surface of liquid is also called evaporation. So simply we confirmed that evaporation is a surface phenomenon. Means evaporation always takes place on the surface of the liquid only, but not involving inner side of the liquid. Simply, evaporation means changing the state of liquid to gases. Changing the state of liquid to gas is called evaporation. But here one important thing is, this phenomenon means this process. The process of evaporation should be done at any temperature. Means here temperature is not important. So that is called evaporation. Simply I will explain. Here take a small plate. This is a liquid. Here evaporation should be takes place on the surface only. Means here the topmost molecules only evaporated from here to gas. Here the liquid can be converting into gas from the surface only, but not the inner molecules. The inner molecules in the liquid may not be involving in the process of evaporation. Only surface of the molecules only participating in the process of evaporation. But how the evaporation going on? Means simple. Here the inner molecules and the outer molecules, number of molecules in this dish. For example, this is water. Here every molecule has an internal energy. So these molecules are moving in a random way. Means one molecule move this side, one molecule move this side. Like here, number of molecules are moving in different directions. In this particular condition, two molecules are collide with each other. That means when two molecules are moving in this way, then both are collide each other. Means collision should be takes place in between these two molecules. When the both molecules are collide each other, then the energy should transfer from one molecule to other molecule. When the collision happens, some energy is created. That energy is transferring from one molecule to other molecule. This is only happening in evaporation. In this particular case, any inner molecule collide with the upper molecule. Then upper, for example, here an inner molecule and here an upper molecule. When an inner molecule is collide with upper molecule, then this upper molecule got some energy from this molecule. Then because of the energy, this is moving upwards. To give the energy in the surface of the molecule, take the energy and it is moving upwards and it want to give the energy which is given by the inner molecule. That energy it want to given to the air molecule. That means because of the energy which is getting by the inner molecule, this outer molecule or the surface molecule moving upwards, and it move upwards and give the energy to the air molecule. This is happening in the evaporation. So only surface of the molecules only jump upwards because of getting energy from the inner molecules. They move upwards and give the energy to the air molecules and again fell down. After giving energy, they again fell down into the same vessel. But here in the process of evaporation, we lost the liquid content in the vessel. Gradually after some time, the liquid presenting in the vessel remains decreases. Why? Because when the molecules in the surface are moving upwards, what happened? It given the energy to the air molecule. At the same time, because of the air presenting in that atmosphere, because of the air, this upper moving molecule moving some distance by the air. Because of air, it moving some distance. After giving the energy to the air molecule, it fell down. But here, no more dish. There is no dish here. So that is why the molecules are escaping from the surface and moving upwards. Then the molecules which are escaping from the surface and again back. But in sometimes most of the molecules are escaping but they may not getting back into the vessel. In that particular situation, evaporation should be takes place. Understand? So this is the process of evaporation. Fine. Next, we go to the reverse process of evaporation. So evaporation is a liquid change in the liquid state to gas state at any temperature. Now, what is the reciprocal? What is the reverse process means? The reverse process of evaporation is condensation. What is condensation? Just simply you are observing. For example, in winter time or if you want to take a bottle from the fridge and put here, after some time some water droplets are forming on the surface of the bottle. But that water is not inside that water does not belongs to the inside of bottle. But how the water droplets forming on the surface of the bottle means that process behind it in the formation of water molecules on the surface of the cool bottle is condensation. What takes place in the formation of water droplets means when you take the water bottle from the fridge, the water in the bottle is cool. This is the cool water. So if you take the bottle outside the fridge, then it is kept in the atmosphere. Our atmosphere, lot of water vapor is there. When these water vapor, when touches the surface of the liquid, the water vapor having more energy. When it touches the surface of the liquid, according to the nature of heat, the water vapor gives the energy or transfers the energy from the molecule water vapor to the bottle and inner water. Means here the inner water taking some energy from the water vapor. So the water vapor gradually losing its energy and the vapor converting into liquid. That is why, because of losing energy, the water droplets are forming on the surface of the bottle. So this process is called condensation. So condensation is the water droplets means vaporized gaseous molecules convert into liquid molecules is called condensation. Gaseous molecules convert into liquid molecules is called condensation at any temperature. Here also temperature is not constant. This process is called condensation. Here in the process of condensation, the water vapor gives some energy to the bottle by losing heat. Means the losing heat, here water vapor lost the heat and the inner water particles are gain the heat. So gradually the temperature in the water bottle and the water in the bottle also increases. So condensation is a warming process. Condensation is a warming process. Why? Because in the process of condensation, the water vapor in the surrounding atmosphere, the temperature or the heat transferring from the water vapor to the bottle water. Here the water gradually, the temperature of the water is increases. So condensation is a warming process. In the similar way, in the evaporation process. In the evaporation process, for example, when you are sweating, when the fan is on, then gradually you feel some coolness. You feel some very cool. Why? Because our sweat gradually evaporated from your sweat glands, the surface of your skin to the atmosphere. So that is where you feel some cool. So evaporation is a cooling process. Here in the process of evaporation, you feel some cool. So evaporation is a cooling process. Means in the process of evaporation, you lost some heat energy from your body to the atmosphere. That is why you feel some coolness. So evaporation is a cooling process and condensation is a warming process. So evaporation means at any temperature, the amount of liquid converts into gaseous molecules is called evaporation. In the reverse way, condensation. Gaseous molecules converts into liquid molecules is called condensation. So this is about evaporation and condensation. Next one is humidity. What is meant by humidity? Humidity. Humidity means, already I told that in our atmosphere, we contain lot of water vapor. But how the water vapor come into the atmosphere? By the evaporation process from the lakes and oceans and rivers and lot of water sources from our sweat also. So all these water vapor having in our atmosphere. So in our surrounding atmosphere containing lot of water vapor. That water vapor containing is nothing but humidity. Humidity is nothing but amount of water vapor in air. Amount of water vapor in air. In our surrounding air, how much water vapor it contains, that is called its humidity. So humidity is nothing but amount of water vapor in air. In air, how much water vapor molecules are in that, that is called humidity. Fine. Next one is dew and fog. These are all the heat basing processes. So dew means what? In the cooling time or in winter seasons, when you early morning, in the early hours, when you coming from your house and look outside, for example, your bike is there in outside at complete night. At morning, you find some droplets on the surface of your bikes. Anybody? So same, how the water droplets formed means that water droplets formed by the basis of dew. The process behind the formation of water droplets on the surface of the bike is dew. So dew is nothing but how the water droplets formed. Means in the winter seasons the night temperatures are very less. Because of the less temperatures, when the water vapor touches any object surface, then automatically the water vapor transfers the energy because the object is very cool. The surface of the object is very cool. When the water droplet moving around the object and touch the object, then automatically it transfers the energy from the water vapor molecule to the object. Simply the water vapor converting into water droplets. That is called dew. The water droplets forming on the surface of a substance is called dew. Here, what process behind in the formation of dew is condensation. Means the water droplets, water vapor converting into water droplets means the gaseous molecules converting into liquid molecules is nothing but condensation. So, in the process of dew, what process behind this? Condensation is behind in the formation of dew. So, what is dew? Dew is the formation of water droplets on the surface of object is called dew. Fine. Then what is fog? Means when the temperature is completely reduces in the winter seasons. In some particular cases, we find lot of fog in the atmosphere. What is fog means? Here, the water droplets forming on the surface of the dust particles in the atmosphere. The surface of the dust particles in the atmosphere is called fog. So, water droplets form in the surface of dust particles. Water droplets form on the surface of the dust particles is called fog. There is a difference in between dew and fog. Dew is formation of water droplets on the surface of objects only. That is called dew. Then what is meant by fog? Fog is nothing but water droplets form on the surface of dust particles is called fog. This is a slight difference, but these two are very important definitions. Dew means formation of water droplets on the surface of object. Fog means water droplets form on the surface of dust particles. The process behind the formation of dew and formation of fog, both are the behind process is condensation. Yes. Next topic is boiling. What is meant by boiling? This is also very important in the 10th class purpose. What is meant by boiling? Boiling also we know observe every year. For example, in our houses also, when you go to kitchen, you observe the process of boiling. When you kept some water on the stove and we switch on the stove, then after some time some water vapor is coming out from the vessel. So in that particular case the water boiled. So what is meant by boiling? Here also the water or liquid convert into gases. The water or liquid convert into gaseous state, liquid state of molecules convert into gaseous state is called boiling. I think It is very little bit related with the word evaporation. Am I right? But there is a difference in between these two, boiling and evaporation. This is very important. So we want to discuss the differences in between boiling and evaporation. So boiling and evaporation. So the similarity in between these two is, in the process of boiling, the liquid molecules convert into gaseous state. Here also liquid molecules convert into gaseous state. Only this similarity is in between boiling and evaporation. But boiling takes place at constant temperature. Boiling takes place at constant temperature, means when you give some heat energy to the liquid molecules or liquid substance, gradually it reaches its heat temperature. But after some time, when you observe by the thermometer, the temperature remains constant. When you giving more and more heat, but the temperature may not be changes. When it is changes up to the mark, then the temperature remains constant. When the temperature reaches up to the mark, then the process of boiling starts. For example, in your house also, when you put a vessel on the stove, then pour some water, when you switch on the stove, then after some time, then the bubbles are starting. Then the bubbling is starting in the stove. That situation is called boiling. When you observe the temperature at this situation, then after some time also, there is no change in the temperature. The boiling is going on. Means in the process of boiling, the temperature is constant. Simple. But in the process of evaporation, the temperature is not constant. At any temperature, evaporation should take place. So evaporation need not any particular temperature. It is done at any temperature. And boiling is not a surface phenomenon. Means boiling is not takes place on the surface. It is totally from the down of the vessel to upper place. Means it is completely whole phenomena. But evaporation is a surface phenomena. Means evaporation is always done on the surface of the liquid only. It's not inside of the liquid. Only evaporation should takes place on the surface only. So these are the common differences in between the boiling and evaporation. So boiling means changes liquid state to gaseous state. But here the temperature is constant. At any pressure, at constant temperature, the amount of liquid molecules changes into gaseous molecules is called boiling. Here, at any temperature, the amount of liquid molecules leaves the surface of the liquid. From the liquid state to gaseous state is called evaporation. So these are the differences in between the boiling and evaporation. Next one, here in the boiling a similarity, a small problem is there. What is that? When you give some more heat after reaching a particular position. For example, in water, when if you take a vessel, you pour some water, when you switch on the stove, after some time, the temperature reaches 100 degrees Celsius. When the water in the vessel reaches 100 degrees Celsius, you continue the heat, but after some time you find the measurement, it shows 100 degrees Celsius only. Means you are continuing giving the heat to the object, but the temperature may not rises. What happened in the vessel? Means here it takes the heat, but what about the heat? Where the heat going on? Means here the heat going on to utilize the liquid molecules into gaseous state. Here the heat, the internal heat, you give the heat, but there is no change in the temperature. Means the hidden heat uses in the conversion of liquid molecules to gaseous state. Means the liquid changes into gaseous form by the using of this heat. So this is called latent heat of vaporization. That heat is called latent heat of vaporization. Means here what heat it takes to the process of boiling, that heat is called, the internal hidden heat is called latent heat of vaporization. So the water's latent heat of vaporization is 540 calorie per grams. For example, here the mass of water is m. You give some heat is q. Here the latent heat of vaporization L is equal to Q by M. This is the formula for the latent heat of vaporization. Here Q is the giving heat to the water and M is the mass of the water and L is the latent heat of vaporization. How much heat it required to the process of boiling is L is equal to Q by M, and the latent heat of vaporization of water is, this is the latent heat of vaporization of water, 540 calorie per gram. From this formula, you derive the units of latent heat of vaporization. How? In CGS. Here Q is the heat. Here units of heat in CGS system is calories. And M is the mass. Here units of CGS system of mass is grams. So, units of latent heat of vaporization in CGS system is calorie per gram. At the same time, the MKS units of latent heat of vaporization is, in MKS, the units of heat is joule. At the same time, the units of mass in MKS system is kilograms. So, the units of latent heat of vaporization in MKS system is joule per kilograms. Here, the latent heat utilized in the water to converting from liquid to gaseous state is 540 calorie per gram. It is very important. So, this is about boiling. Next. Next topic is melting. So, melting is a process. In this process, the amount of solid substance converting into liquid. The amount of solid substance converting into liquid at constant temperature at any pressure is called melting. So melting is nothing but a substance which is in solid state converting into liquid state is called melting. Okay, so how it takes place? Similar in the way of boiling. So here also some hidden content, hidden heat involved in the process of converting solid into liquid. That hidden heat is called latent heat of fusion. Here in the process of melting, the hidden heat which is used in the substance to convert the solid into liquid is latent heat of fusion. Here the latent heat of fusion of ice is latent heat of fusion. For example, some of the ice you kept from the, you take out from the fish, and after some time the ice can be converting into water gradually. Here this process, the ice is a solid substance and water is a liquid substance. So the solid substance converting into liquid substance, this process is called melting. Here also the temperature is constant. This process also done in the constant temperature. When the ice can be converting into water, some hidden heat utilizing to conversion of ice into water. That hidden heat is called latent heat of fusion. So latent heat of fusion of ice is 80 calorie per gram. This is very important. Latent heat of fusion of ice is 80 calorie per gram. Here the at which temperature the solid can be converting into liquid, that point is called melting point. At which constant temperature the solid can be converting into liquid, that temperature is called, that point of temperature is called melting point, and the melting point of water is 0 degrees Celsius. In kelvins, 273 kelvins. At the same time, the boiling point of water is 100 degrees Celsius. In kelvins, 373 kelvins. So this is the boiling point of water, 100 degrees Celsius in Celsius grade or 373 kelvins. And melting point of water, 0 degrees Celsius and in kelvins, 273 kelvins. So this is about melting. And the last point is very important. This is also freezing. Freezing is nothing but you observe in winter days. For example, you go to your kitchen and you take your oil. When that oil is in the form of solid state, means actually the oil is in the position of liquid, but the oil is in the state of solid state. So that amount of liquid conversion into solid is called freezing. Freezing is nothing but liquid form of a substance can be converting into solid form, that is called freezing. That is regularly happening in our regular things. So what about when the water put in the fridge, what happened? It converting into ice. What about the volume of water and ice? For example, if you take a bottle, you completely pour the water up to the mark. Completely you pour the water up to the mark and tighten it and put it in the fridge, in the deep freeze. And after some time, if you take the bottle from the fridge, definitely some brittles happening in the bottle. That means the bottle will be brittled. The bottle brittle means పగిలిపోవడం అంటారు కదా, అలా లైట్ గా విరిగిపోతుంది అనమాట. సో ద బాటిల్ brittle. So why here the volume of water is 1 liter. After freezing also the mass of the water is 1 liter only. But what about in the liquid state, it is existing in the bottle, but whereas it converting into the ice, it may not existing in the bottle. That is where the bottle brittled. So why it takes place means the volume of water and volume of ice is not equal. The volume of ice is little bit more than water. Understand? That is why the bottle brittled means in the form of ice, the bottle not existed. That is why the bottle brittled. So the volume of ice is more than volume of water. Why? Because in the water form, the water molecules are close to each other. But whereas in ice, the molecules are apart from each other. So that is why the volume of ice is increased than the water. Simply because of this reason only, the ice floated on the water. Both are the same. This is solid form, this is liquid form. Water is in liquid form, ice is in solid form. But ice floated on water. Why? Because the volume of ice is more than volume of water. Because of the more volume, the ice density is less. Because of volume, the density is decreases. So the density of ice is less than water. So because of the less density of the ice is floated on the water. So these are the important topics in the heat. Thank you so much.